This short talk is at Cheer 2022. It's for the long paper titled Learner, Assignment, and Domain, Contextualizing Search for Comprehension. The authors are Kathy Smith, Kelsey Ergo, Jaime Arguello, and Rob Capra. The first author is presenting. This position paper is the product of our discussions on how a search system could be designed to enhance the user's comprehension of retrieved resources in an academic learning context. We're interested in what the system might model about a learner, the learner's assignment, and the domain of the assignment. We limited our discussions to undergraduate education in order to constrain our conversation to cases where we can assume a learning management system provides access to data about individual learners and their assignments. We believe our ideas could be extended to other types of educational contexts. The objective of our hypothetical search system is to maximize comprehension for a learner. We selected comprehension as our learning goal precisely because it may be the most challenging objective function for a retrieval system that supports search as learning. We want our users not only to remember what they encounter, but to successfully apply new understanding in novel contexts. In short, we're focused on deep human learning. We started by asking, what could a hypothetical retrieval system know that might enhance comprehension? As is clear in the paper, we considered this question from several different perspectives. In one dimension, we asked, what can the system know about the learner? And in the other dimension, we asked, what can the system know about the learner's learning context? We see these as independent factors, with learning context defined as a domain of study and a learning assignment in that domain. Our thinking and discussions in each of these areas have drawn on reading in many research areas mentioned in the paper, principally in areas of learning psychology, multi-text comprehension, reading processes, text analysis, and domain analysis. On the learner side, our hypothetical system starts with a relatively static profile of an individual learner's skills and educational background. A set of dynamic models also represent the individual learner, with one model for each domain of study. These models are created as a learner continues to use the system over an extended period of weeks, months, or years. The models estimate the learner's knowledge and learning progress in each domain of study. On the context side, relatively static models are used to infer structure, content, and other aspects of academic domains of study. The domain models inform models of individual academic assignments. At the heart of the design, a single model is created to represent the knowledge state and task progress of a specific individual learner in relation to a specific individual assignment. This learner assignment model represents the learner's knowledge in relation to knowledge gains expected when the learner completes the assignment successfully. The model also represents the learner's progress toward objective assignment outcomes. We take the position that the learner's comprehension of learning materials is necessary for successful completion of the assignment and its learning goals. We don't claim that comprehension is sufficient. Of course, we're modeling only domains and assignments that can be supported by a search system, not all learning domains, and of course, we're focused on learning that requires comprehension. The learner assignment model has the job of informing the retrieval model with features that support comprehension in the next search session. In the paper, we go into some detail on how the learner assignment model might be initialized and updated, and we speculate on the types of features that might inform the retrieval model. Finally, two other hypothetical components support retrieval for comprehension. First is a model that uses observations of behavior to predict the learner's comprehension of concepts presented in each information source encountered. Observations include eye tracking, mouse movement, and the content of text written by the learner, for example. Of course, comprehension is always relative to an information source, so the behavior model is informed by a corpus model enriched with features associated with the structure of a source and its conceptual content. In the paper, we suggest that many of the components and much of the learning theory needed for progress on these models are already under study in research areas adjacent to information retrieval. The object of our paper is to prompt discussion on how to leverage that work to align a set of interlocking research questions that advance the search as learning program. We'll conclude here by touching on two specific ideas among the many that we've mentioned in the framework. Essential in our end-to-end system is a representation of the learner's knowledge state in the domain. We propose to model this at two levels. First is prior knowledge in the domain without respect to pedagogy. This model updates at the completion of every assignment in the domain. The second level expresses knowledge state as a relation between the learner's prior knowledge and knowledge gains expected with successful attainment of a learning goal. This model is updated at the conclusion of every search session associated with an assignment. The general idea is that the retrieval system can be advantaged if it starts a search session with information about knowledge still needed for successful completion of the assignment. Of course, there are many research questions here. Beyond the question of how to derive expected knowledge from assignments, there are many questions on how the retrieval system can use features of knowledge state to optimize for comprehension. We also propose a construct for information utility, which expresses the expected value of an information source for a specific learner working on a specific goal. The retrieval model uses information utilities to favor resources most likely to contain concepts the learner has yet to fully comprehend, where the learner is likely to learn those concepts with less effort. The corpus model expresses the conceptual content of information sources. A learner may need to learn all or some of that content to reach a learning goal. Thus, the value of a resource depends on how much knowledge can be gained from the resource, which is dependent on the learner's prior knowledge and goal. The corpus model also captures the features that affect learning effort, such as the format and readability of a resource. For different learners, these features will have smaller or larger effects on effort. The retrieval model uses estimates of learning gain and effort in ranking resources for optimal comprehension for the learner working on the assignment. Research questions here focus on understanding which document features affect learning effort and the effect of those features on effort. Also important is the question of how learning is affected by trade-offs between effort and learning gains. Clearly, the goal of our position paper has been to open conversations about many dimensions and ideas for research in search as learning. Thank you for your attention, and we look forward to your comments and questions.